In this video, we want to do some questions about multiplying, dividing, and raising to a power in complex numbers. 1 plus I to the power of 2026. Of course, it's not a good idea to think that we can solve this question by multiplying 1 plus I 2026 times by itself. So we have to think to another method to solve this question. Instead of raising 1 plus I to the power of 2026, let's see what is 1 plus I to the power of 2 first. 1 plus I to the 2 is 1 plus I times 1 plus I. If we multiply the two brackets by each other, 1 times 1 is 1, 1 times I is I times 1 is another I, and I times I is I to the 2. We know that I in the complex number is the square root of negative 1, and I to the 2 equals negative 1. So here we have I to the 2, and I to the 2 is negative 1. Negative 1 plus 1 is 0. I plus I is 2I. So now we know that 1 plus I to the power of 2 is 2I. And this can be so helpful for us to raise 1 plus I to the power of 2026. But how? Here, note that we can write 1 plus I to the power of 2026 in the form of 1 plus I to the 2 all to the power of 1013. Attention, if we multiply this power by this power, we have 2026. So, we write 1 plus I to the power of 2026 in the form of 1 plus I to the 2 all to the power of 1013. We know that 1 plus I to the 2 is 2I. So, we can write this as 2I, because this expression is exactly 2I. So we write the expression inside the bracket as 2I, and now we have to raise this to the power of 1013. Why this is much better than this? Because now we have only one single term in the bracket, and simply we have to raise 2 to the power of 1013 and I to the power of 1013. So this equals to 2 to the power of 1013 times by I to the power of 1013. Now we have to simplify this. I to the power of 1013 can be written as I to the power of 1013 can be written as I, we separate one I, times by I to the 1012. The reason that we write this in this form is that we want to have imaginary number I with even power. But why we want I to the power of even number? Because of this property. I to the 2 is negative 1. So now we can use this. We can write this as I times by I to the 2 to the power of 506. 2 times 506 is 1012. I to the 2 is negative 1. So this equals to I times negative 1 to the power of 506. Negative 1 to the power of 506, because the power is even, is equal to 1. The negative cancels. So, negative 1 to the 506 is 1. 1 times I equals I. So we can write this in the form of, this is I times by this. And this is our final answer for this question. 2 to the power of 1013 times by I. So 1 plus I to the power of 2026 is equal to 2 to the power of 1013 times I. Please pay attention. You don't need to even think to calculate this. This is a very big number. Leave your answer in this form. And attention, we have written our answer in the form of a plus bi, which in this number, this coefficient of I is basically b, and the real part of this complex number, which is the answer of this question, is 0, because we don't have any real part in our answer here. Well, let's move to the next question. 1 plus I over 1 minus I raised to the power of 13. The power in this example is smaller, but inside the bracket we have a division. So you can do this question in two ways. One way is this, to say 1 plus I to the power of 13 divided by 1 minus I to the power of 13, and calculate the numerator and the denominator like the previous example, and then divide the two answers by each other. But the better way and the easier way is to do the division in the bracket and then raise it to the power of 13. So first, we start by dividing 1 plus I by 1 minus I. We know that to divide two complex numbers, we multiply numerator and denominator by the conjugate of the denominator, conjugate of the complex number in the denominator. What is conjugate of 1 minus I? The conjugate of 1 minus I is 1 plus I. So we multiply numerator and denominator by 1 plus I. This is the method for dividing two complex numbers. Multiply numerator by numerator, denominator by denominator. 1 plus I times 1 plus I, if you multiply term by term, you would have 1 plus I plus I plus I to the 2. For the denominator, if you multiply 1 minus I by 1 plus I, the answer at the end would be 2. Let me tell you the reason. When we multiply 1 minus I 1 by 1 plus I, these two are conjugate of each other. And remember, we have this identity in algebra. A minus b times a plus b is a2 minus b2. Based on this identity, this equals to 1 to the 2 minus I to the 2. 1 to the 2 is 1, I to the 2 is negative 1, and this equals 2. But if you have watched my other videos in complex numbers, probably you know that when you are multiplying a complex number by its conjugate, you can find the answer even faster than this method. That method is this. If you multiply a complex number by its conjugate, always the answer is raise the real part, which in this case is 1 to the 2, plus what is coefficient of I here or here? The coefficient of I in this bracket is negative 1, in the other bracket is positive 1. The answer of multiplying any complex number by its conjugate is always the real part to the power of 2 plus imaginary part to the power of 2. So here the answer is 1 to the 2 plus another 1 or negative 1 to the 2. So this equals to 1 to the 2 plus 1 to the 2. Let me explain this again. When we multiply a complex number by its conjugate, even you don't need to do any of these calculations. You can find this answer right away. Just raise the real part to the 2 plus coefficient of imaginary part, which is 1 to the 2. And 1 to the 2 plus 1 to the 2 is 2. So here, let's continue our calculation from here. We have I to the 2, which is negative 1, plus 1 is 0. I plus I is 2i, so we have 2i divided by 2 and it equals I. So for this question, the answer is I to the 13, and we can write this simply as I times I to the 12. I to the 12 is I to the 2 to the 6. I to the 2 is negative 1, negative 1 to the 6 is 1, so the answer is I. Now look at this interesting question. What is the sum of 1 plus I to the 2, plus I to the 3, plus I to the 4, plus I to the 5, and so on, up to I to the 100? We want to add all of these complex numbers. Before we start, let me ask you a question. How many terms we have in this sum? 10 terms, 20, 100, or even more? How many terms we have in this sum? Please pay attention. The first term is 1. So please pay attention. The first term is 1, which you can consider it as I to the 0. Then we have I to the 1 plus I to the 2 up to I to the 100. So how many terms in total we have in this sum? Is it 100 or 101? It is 101. Because here, if you pay attention, from I to the 1 to I to the 100, this is exactly 100 terms. But we have this term here. So in total, we have 101 terms, not 100 terms. But why this is important? We will see why this is important in a moment. For solving this question, I will show you two different methods. Before we start, let me remind you that I is a square root of negative 1, and we know that I to the 2 is negative 1. If I to the 2 is negative 1, what is I to the 3? I to the 3 is I times I to the 2. I to the 2 is negative 1. So I to the 3 is negative 1 times I, so it equals negative I. So paste what I have written here. Now let's back to our question. We want to calculate this sum. We can write this sum in the form of 1 plus I to the 2 plus I to the 3. We group this sum in this form. Then we have I to the 4, I to the 5, I to the 6, I to the 7. I group them in form of 4 consecutive terms. Then in another bracket we have I to the 8, I to the 9, I to the 10, I to the 11. Attention, in each bracket we start with I to a power that is a multiple of 4. This one is 4, the next one is 8, the next one here is 12, and so on. If we continue this, if we continue writing this, finally we have a term with I to the power of 96, I to the power of 97, I to the power of 98, I to the power of 99. And the final term would remain by itself, I to the 100. So we can write this sum in this form. It should be clear. Now, look at here. I to the 2 is negative 1. So this term here is negative 1. And I to the 3 is negative I. So what is the sum of the terms in the first bracket? I to the 2 is negative 1. And I to the 3 is negative I. 1 plus negative 1 is 0. I plus negative I is 0. So the sum of the terms in the first bracket is 0. But if you pay attention, I to the 4 in the next bracket is 1. Let me tell you the reason why I to the 4 is 1. Because I to the 4 is basically I to the 2 to the 2. And this is negative 1 to the 2. It equals 1. So this is like 1 But I to the 5 can be written as I to the 4 times I. I to the 4 is 1, so this is like I. So this term is I. In a similar way, you can check that I to the 6 is like I to the 2. And I to the 7 is like I to the 3. So, look at this. What we have in the second bracket. The first term is like 1 is equal to 1. The next term is I to the 2, I to the 3. But already we know that 1 plus I2 plus I3 is 0. So the sum of the terms in the second bracket is also 0. Probably you can guess that the sum of the terms in the third bracket, this is also 0. And all the brackets, the sum of the terms in each bracket is 0. So at the end we have only I to the 100. I to the 100 is I to the 2 to the 50, which is negative 1 to the 50, and it equals 1. So the sum of the terms is equal to 1. Now let me show you another method for this question. So we want to find the sum of 1 plus I to the 2 plus I to the 3, I to the 4, I to the 5, and so on up to I to the 100. This method is based on a formula that we know from the sum of geometric series. The first method that I showed you was more basic and you don't need to remember any formula, but this method is shorter, but the thing is that you need to know the formula for sum of geometric series. Let me remind you, in the geometric series, when we have A plus A times R plus A times R to the 2 plus A times R to the 3 and so on up to A times R to a power like n minus 1. So A plus AR plus AR to the 2 plus AR to the 3 and so on up to A times R to the n minus 1. The sum is A times 1 minus R to the n over 1 minus R. This is the sum of these terms here. And this is a geometric series. We can use this formula to find this sum. If you pay attention, in this sum, the first term A is 1. What is the ratio in this sum? What is the ratio of the geometric series here? If you pay attention, the ratio is I. Because if you pay attention, when we multiply 1 by I, we get this term. When we multiply this by another I, we get to the next term. By another I, and so on. So, it is clear that we have a geometric series here. Here we have a geometric series that its first term is 1 and its ratio or R is I. The only thing that we have to figure out to use this formula is n. N here is the number of the terms in the geometric series. How many terms we have in total in this geometric series? As we talked about this before, here we have 101 terms in this geometric series. Another way that you can figure out that is that pay attention in this formula here. When here the power is n minus 1, in this formula, in the right side, we have power n. So, if here is 100, the n that we have to plug in here would be 101, because if it is n minus 1, we substitute n in the right side. So, if it is 100, in the right side we add 1 to the power, and 101 we have to substitute in the formula. So now everything is ready. So in this sum, the first term is 1. The ratio is I, and n is 101. So again, what is n? N is the number of terms in the geometric series that we want to add the terms. Based on the formula that we have here, the sum equals to a. In this sum, the first term, which is a, is 1 times by 1 minus ratio. Ratio is I to the power of 101 all over 1 minus ratio, which is I. Attention that I to the 101 is like I times by I to the 100. I to the 100 is I to the 2 to the 50. I to the 2 is negative 1. Negative 1 to the 50 is 1. So this equals I. Because I to the 2 is negative 1. And negative 1 to the 50 is 1. Because I to the 101 is I, so this equals to 1 minus I over 1 minus I. Numerator is 1 minus I. Denominator is also 1 minus I. And attention, this 1, if you multiply this in this bracket, it's the same expression. Doesn't change anything. 1 minus I over 1 minus I equals 1. So this sum is 1. Same answer as the other method. It's up to you which method do you like here. Do you prefer to use direct method, or do you prefer to use the sum of geometric series formula? Now we have a multiplication between two complex numbers, but it is a bit unusual that the complex numbers include cosine and sine. We want to multiply cosine theta plus I sine theta by cosine theta minus I sine theta, and here we don't want to use any polar form or exponential form, things like that. Directly we want to multiply these two brackets by each other and we want to calculate this. So let us start. We remember that when we have a plus b times by a minus b, the formula of a plus b times a minus b is a2 minus b2. So here we have this equals to, so this equals to a to the 2, which is cosine to the 2, minus I2 sine to the 2, a to the 2 minus b to the 2. But we know that I to the 2 is negative 1. Because I to the 2 is negative 1, so this equals to cosine to the 2 plus sine to the 2. But we remember from trigonometry this, that sine to the 2 plus cosine to the 2 is always 1, so this equals 1. This is the answer of this question. Here we want to divide two complex numbers by each other. If you remember, to divide two complex numbers by each other, usually the method is this. We multiply numerator and denominator by the conjugate of the denominator. In the denominator we have this complex number, which here, this is the real part of this complex number, and this is the imaginary part of the complex number. So what is the conjugate of the denominator? The conjugate of the denominator is 1 plus sine theta plus I cosine theta. 1 plus sine theta plus I cosine theta. This is the conjugate of denominator. Now simply we multiply numerator by numerator, denominator by denominator. First, let's multiply denominator by denominator. So we want to multiply 1 plus sine theta minus I cosine theta by 1 plus sine theta plus I cosine theta. Here, note that if you suppose this as A and this as B, we have A minus B times by a plus b. So for the denominator we have 1 plus sine theta to the 2 minus I squared cosine squared. And later we can simplify the denominator more. But before we continue in the numerator, please pay attention. I have repeated this several times in my videos. When you multiply a number, a complex number, by its conjugate, even you don't really need to write this. The answer of multiplying any complex number by its conjugate is always the real part to the 2, which would be this, plus just the imaginary part, which is cosine to the 2. So instead of writing this answer in this form, you can write away, say, if we multiply this by this, the answer is 1 plus sine to the 2 plus cosine to the 2. And basically, if you pay attention, if you simplify this, I to the 2 is negative 1 times negative. At the end, you would get cosine to the 2. Let's simplify numerator. To multiply numerator, we have to multiply the terms in the numerator, the first numerator by the second numerator. But attention, the numerators are the same expressions. If you are familiar with a plus b plus c to the 2 identity, then you can use that method. But directly also you can multiply numerator by numerator here. So 1 plus sine theta plus I cosine theta times by 1 plus sine theta plus I cosine theta. Let's see what is the answer of this. We multiply 10 by 10. 1 times 1, we have 1. 1 times sine is sine theta. 1 times I cosine theta, we have I cosine theta. Now let's multiply sine theta from first bracket in the second bracket. Sine theta times 1 is sine theta. Sine theta times sine theta is sine to the 2. Then sine theta times I cosine is I sine theta cosine theta. Now we have to multiply I cosine theta in the second bracket. I cosine theta times 1 is I cosine theta. I cosine times sine is I sine theta cosine theta. And finally we have I cosine times I cosine, which is I to the 2 cosine to the 2. Let's see what we have here. 1 plus 2 sine theta plus 2i cosine theta sine to the 2. We have sine to the 2. I2 cosine to the 2, this term is basically negative cosine to the 2. Because I to the 2 is negative 1, so I to the 2 cosine to the 2 is just negative cosine to the 2. And so far we have written this, and this term plus this term is 2i sine theta cosine theta. Now let's group real terms by each other and imaginary terms by each other. So basically we have 1 plus 2 sine theta plus sine squared theta minus cosine squared theta. And we have this term and this term as the imaginary part. So we have, if we factor a 2i from these two terms, or I basically, we can write this in the form of 2 cosine theta plus 2 sine theta cosine theta times by I. Look at here. 1 minus cosine to the 2 is sine to the 2. If you remember, we know that sine to the 2 plus cosine to the 2 is always 1. Because this sum is 1, if we move cosine to the 2 to the other side, we know that 1 minus cosine to the 2 is sine to the 2. So here, it helps us to simplify our answer here. 1 minus cosine to the 2 can be replaced by sine to the 2. So we have to add another sine to the 2 to here. But sine to the 2 plus sine to the 2 is 2 sine to the 2. So we have basically plus 2 sine to the 2. Now we can see that in here 2 sine theta is common between these two terms. So we can factor a 2 sine theta here. So we can write this as 2 sine theta times 1 plus sine theta. Now look at this bracket. We can factor a 2 cosine theta from these two terms. So we can write this in the form of 2 cosine theta times by 1 plus sine theta. So we factor 2 cosine theta from these two terms that here we have. When we factor 2 cosine theta, we have 1 plus sine theta. So the answer of multiplying numerator by numerator is 2 sine theta times by 1 plus sine theta plus 2 cosine theta times 1 plus sine theta I. Now let's focus in the denominator. In denominator we have 1 plus sine theta to the 2. 1 plus sine theta to the 2 is basically 1 plus sine theta times by 1 plus sine theta. So this is 1 plus sine times by another 1 plus sine. If we multiply 1 plus sine by itself, it equals 1 times 1, 1. Sine times 1, sine theta. Another sine times by 1, it would be 2 sine. And sine times sine is sine to the 2. So this is 1 plus 2 sine plus sine to the 2. So this expression is 1 plus 2 sine theta plus sine to the 2. Negative I to the 2 is negative of negative 1. So it's 1 plus cosine to the 2. So this is cosine to the 2. So plus cosine to the 2. This is the denominator. But we know that sine to the 2 plus cosine to the 2 is 1. So the sum of these two terms is 1. 1 plus 1 is 2. So this denominator can be simplified to 2 plus 2 sine. Again, this is 1 plus another 1 is 2. 2 plus 2 sine theta. So this denominator can be written as, so all of the denominator here is 2 plus 2 sine theta. But 2 is common, so let's factor the 2 here also. So we have 2 times 1 plus sine theta. Now look at the numerator. And look at the denominator. As you can see, in numerator, we have in both of the terms, in this term and in this term, we have 1 plus sine and 1 plus sine. So we can factor this 1 plus sine from numerator and we can cancel with the denominator. Also, the terms in numerator have a 2 here and a 2 here. So we can factor that 2 from numerator and cancel with the denominator. So, if we factor a 1 plus sine theta from numerator and also a 2 from numerator and cancel it with the denominator, 2 if we factor, and these two terms if we factor cancels with this. So what remains in numerator? From denominator we have only 1. In numerator we have sine theta plus I cosine theta. Let me explain what happened in numerator and we got this. In numerator, before cancellation, in numerator before cancellation. Let me erase these. We have 2 sine theta times 1 plus sine theta plus 2 cosine theta times 1 plus sine theta. We can factor in numerator. In numerator, we can factor a 2 and a 1 plus sine theta, because this is common in both of them. From the first term, we have only sine theta. From the second term, when we factor a 2 and this, it remains this cosine and this I. We have I cosine theta. This is what happens in numerator when we factor that. In the denominator, we have exactly 2 times 1 plus sine theta. This completely cancels with this, and this is the answer that we have here. I hope by watching this video you have learned more about multiplying, dividing, raising to a power in complex numbers. If you like this video, please subscribe in my channel and see you in the next videos.